This is the first video on decimals. We're going to be looking at rounding, particularly to a given number of significant figures. First, I'm going to give you a reminder of decimal places. That's the number of figures after the decimal point, and rounding. So, for example here, 14.649, there are 3 digits after the decimal point, the 6, the 4 and the 9. So that's 3 decimal places. If I want to round it to 1 decimal place, that's 1 digit after the decimal point. I've either to round to 14.6 or 14.7 because 14.649 lies between 14.6 and 14.7. So it's a case of which is it nearest to. Is it nearer the 14.6 or nearer the 14.7? Well, the halfway position is 14.65. This is 14.64. The 9's irrelevant. So 14.64 is below the halfway position. So 14.64 falls below 14.65, so it's nearer 14.6. So basically, the round off position, the first decimal place is that 6. It's followed by a 4, so it rounded down to 14.6. If the number following the round off position is less than 5, 5 being a halfway position, then you would round down. If the number following the round off position that is following that 6 was a 5 or more, you would round up to the 14.7. So it lies between 14.6 and 14.7. It's which is it nearest to. You can get that by the digit immediately following the round off position. So here's 45.2831. To 1 decimal place, it's either 45.2 or 45.3 because it lies between these two. So you either round down to 45.2 or up to 45.3. 45.25 is a halfway position. So the round off position is at 2, the first decimal place. It's followed by an 8. That's more than 5, so you round up. 14.28 would be above the halfway position, nearer to 45.3. So they've been rounded to 1 decimal place, 1 number following the decimal point, and it's the number after the round off position, this 4 or this 8 here, that determines whether you round up or down. The other digits don't matter. So here's the same number. Want to round to 2 decimal places, so the second decimal place is this 4, it's followed by a 9. So you're either going 14.64 or 14.65. The number following the round off position is a 9. 14.649 takes you up here somewhere, just short of 14.65. So it rounds up to 14.65. The 9 made that 4 round up to a 5. So it's the number following the round off position is at 5 or more, round up. Is it less than 5, round down. Here's 45.2831. Is it 45.28 or 45.29? It's between the two of them. The number following the round off position is a 3, 45.283. 45.283 falls short of the halfway position, so it's near 45.28. If you click the link description, you can get access to this worksheet, which will ask you to round these numbers, in this case to 1 decimal place, the second question 2 decimal places. The answer will be on the worksheets. So if you click the link description, you get access to the worksheet with the answers, and that's rounding to a given number of decimal places. Significant figures is the number of figures in a measurement that tells you about the accuracy. So to do with measurement, you measure something to a certain degree of accuracy. That's different from counting. If you count things, you can be exact. If you measure things, you're never exact. There's always an approximation involved. There's always a rounding off involved. So if someone measures something at 34 metres, it's assumed you've measured it as 34 metres as opposed to 33 metres or 35 metres. In other words, you've been accurate to the nearest metre. Now, if you measured something and it was 34 metres, you would say that's two significant figures. We've used two figures. If you change the units to centimetres, multiplying by 100 sticks two zeros on the end, 3,400 centimetres. The measurement hasn't become more accurate, you've just changed the units. So this is also two significant figures, because only two figures, the 3 and the 4, tell you about accuracy. The other two zeros mean no tens and no units. It's to keep the place value of the 3 and the 4. So you know this is 400 and you know this is 3,000. So these zeros are not significant because they don't tell you about accuracy of measurement. They only tell you about the place value of the 3 and the 4. Similarly, if I take 34 metres and divide by 1,000, I turn the metres into kilometres. These zeros keep no units and no tenths, but they don't tell you about accuracy. So the measurement's still two significant figures because that's the accuracy. These two zeros at the start aren't significant. So the zeros at the start of a decimal don't tell you about accuracy, they only tell you about place value. They are not significant figures. And zeros at the end of a whole number don't tell you about accuracy, they only tell you about place value. So they're not significant. So zeros don't count as being significant at the start of a decimal or the end of a whole number. These are all two significant figures. If, however, a measurement was given as 34.0 metres, we assume you've measured it so you know it's not 34.1 or 33.9. So you'll be more accurate this time. That was between 33 and 35. This is between 34.1 and 33.9. So this is three significant figures. It's more accurate than saying 34. And if you divide that by 1,000, we would keep this 0 on the end of the 4 here because we're telling accuracy with this 0. 0.0340 is three significant figures. It's more accurate than 0.034. So the first two zeros are place value. They're not significant, but the 0 at the end here is telling you about accuracy. So 34.0 metres is 0.0340 kilometres. This 0 is telling you about accuracy. So it counts as being significant. Now, if you were to multiply that by 100 and turn it into centimetres, you'd still have two significant figures. Turning 34.0 metres into centimetres, you can't indicate accuracy being three significant figures. So it only works with this case, turning it into kilometres. You can indicate the accuracy with this 0. You can't do so when you turn it into centimetres. So the number of figures used is significant figures, but not zeros at the start of a decimal or the end of a whole number. So, for example here, the zeros at the start are place value zeros. They don't tell you about accuracy. That's one significant figure. Here, the zeros at the start aren't telling you about accuracy, but the one at the end is. That's two significant figures. So this 0 counts. Here, the 0 at the start doesn't count, but the one at the end does. That's four significant figures. So just at the start of the decimal, the zeros are only telling you about place value. This is a decimal, but it's no zeros at the start, so they're all significant, three significant figures. These zeros at the end are telling you about accuracy. Here, one significant figure, the zeros at the end of the whole number aren't telling you about accuracy, it's just saying no units, no tens, no hundreds. This is 9,000. One significant figure. Here, the zeros at the end don't count as being significant, three significant figures. Here the 0 at the end doesn't count, it's got four significant figures. So notice just at the end they don't count here on the whole numbers. Here it's a decimal point, zeros don't count at the start, but it starts with an 8, so they're all significant, they're all telling you about accuracy. That's 4. So it's just an awkward case of zeros. They don't count at the very start of a decimal or the very end of a whole number. That's a number without a decimal point. Click the link in the description, you'll get access to a worksheet which will practice this. But here is rounding, which will also involve rounding. And here, that's 5 significant figures. If you want to round it to 2, that's the 5 and the 7. But you've got to indicate there are no tens and there are no units, so we have to put zeros in for 0 tens and 0 units. So here, first two figures, 5 and 7, the 7's in the hundreds column. It's equivalent to rounding this to the nearest 100. So you want to round off to that position, the nearest 100. That's 5700. Notice no tens, no units, but these are not significant figures because they're only telling you about place value. These are the two significant figures. So that's rounded to 2. If you want to round this to two significant figures, that's first two zeros are not significant. The 5 and the 7 are the two significant figures, so you're going to round it to that 7. That's in the thousandths, 7 thousandths. You're rounding off to that position. So that is to the nearest thousandth, 0.057, two significant figures. No zeros on the end, because we don't need to tell that there are zeros here to give place value. The zeros at the start give place value. So if you wrote that with zeros replacing these missing digits, that would be 5 significant figures, not 2. So zeros at the end of a whole number, not significant. Zeros at the start of a decimal, not significant, but they're significant everywhere else. So that's 5, because these would be 3 significant figures here. So the worksheet, if you click the link description, you'll get the worksheet, which is to say the number of significant figures this has, and here to round to two significant figures. The answers will be with them, so I'll have the answers on them as well. So that's significant figures and rounding. Where we mainly use it is in questions where you're asked to carry out some calculation. So here you use a calculator, work out the top line, work out the bottom line, divide the top by the bottom. There would be the answer, and then answer correct to two significant figures. So there'll be a rounding off at the end. That's a second significant figure is this second 5. You knock away the extra figures, it rounds up because it's followed by that 6. So that's two significant figures. The zeros are not significant. Here, work out the multiplication and that division. Carry out the subtraction. That's 5 significant figures. Round it to 2. That's the 1 and the 2. But we need to, when we knock away the extra figures, you have to say no units. So that's not a significant figure, that's 0. Just say no units. It's rounded down to 120. So that's to two significant figures. So at the end of a calculation, there's a bit of rounding to be done. So that's how we use significant figures, just for rounding at the end of a calculation. Or if we want to carry out an estimate, we want the area of a rectangle, we multiply length and breadth. We want a rough idea of the answer. We would use these figures to one significant figure, 43.65 centimetres, to one significant figure is 40 centimetres, and this 18.37 centimetres is to one significant figure, 20 centimetres. So you're going to multiply 40 by 20, it's approximately 800 square centimetres, so that's estimated an answer. So you can get a worksheet using the link description. There's also notes there, decimals and rounding, significant figures and rounding. The next video will be on non-calculator decimal calculations, and hope you found this video useful.